So this is a very quick summary of programming. If you actually learned any programming, this should be very easy for you. If you've never done it, it's not hard. President Obama learned to code at Code Academy. If you've never done any coding at all, that's what Code Academy is for. It's a free online game you can play, and it teaches you simple languages. Yeah? Are we really on chapter 6? Well, that would be a serious flaw.
I just took the quiz for it.
Well, George, you're right. Well, thank you. Good. Don't let me do that. I'm glad somebody's paying attention.
You should get extra credit for that.
Maybe you should. I thank you. All right. I get confused, especially now I've prepared quizzes so much in advance. All right, we'll do enumeration. Thank you. All right, so we'll get to that programming next time then. Anyway, enumeration. This is something that came out pretty much because of a very bizarre Microsoft thing called null sessions. It turned out, this is not obvious at all, but it turns out that there is a way to get information about what resources are available on a network without yet exploiting them. A listing about the shares that are there, the topology, what machines you might want to attack, even a list of what user accounts there are. You might get all this without really doing much in the way of exploiting or finding a password or anything, because Microsoft Windows networks released a lot of this information pretty much to the whole world for a long time. So before this, you do port scanning and footprinting. Footprinting is just looking from the outside for things like news articles and blog posts about a company. And then port scanning, we talked about last time, is finding out which TCP ports are open, and UDP sometimes, to see what services you can attack. But enumeration goes further, so you do port scan, you find port 135 open and port 445 open, indicating that there are some Windows shares available. And then you can connect and get a list of all the shared folders and see what's out there. NetBIOS is a very old protocol used for file sharing. It's been around since before the internet. Long ago, before there was the internet, like in the 70s and 80s, there were local area networks where computers would connect and share a printer within one room. And there were 4 different protocols in use at that time: AppleTalk and NetBIOS and IPX, SPX, and I think the 4th one might have been TCP/IP, very rarely used. And there was, in fact, a lot of people got used to these because it was very easy to use things. You didn't have any numbers anywhere. You would just name things like Rick HP and Sam Laptop and so on. That would be the address. You would network it by the name. Because you just had a local area network, you'd have maybe 3 or 4 devices. It really didn't matter. And people resisted very much moving to TCP/IP, where you had to have these IP addresses and subnet masks and gateways, and people didn't even understand what that stuff was. But that's because that had to be a system so complicated it could organize the entire internet instead of just a few computers in one room. Or I could have something just called printer, and everybody else could have something just called printer, and since the rooms are all separated, it's okay for us all to just use the same name. But that NetBIOS is the one Microsoft used, which I think originally came from IBM, I'm not sure. But anyway, you'd have this NetBIOS name, which could be up to 15 characters, and then there were a byte at the end that told you what sort of thing it was. And then, in a story you're going to hear over and over and over, especially about Windows systems, something intended to run on a small scale was just transported to the internet by moving it over IP. Telnet is one good example for this. Telnet was originally intended to carry data down a wire from your keyboard to your computer right there. So nobody thought about encryption or anything because it was just supposed to be going down one wire to one destination. And then when the internet came out, they just put those packets over IP and made Telnet over IP, which exposes your data to the whole world, but nobody thought of that. And the same thing happens here. This NetBIOS then became NetBIOS over TCP/IP, so you could now use Windows file sharing over the internet, over a network of any size. And programs that were originally intended to run in a nice, safe, contained environment were now exposed to the whole internet, creating a ton of security problems. Anyway, so knowing the versions of Windows helps a lot in finding vulnerabilities, especially old versions. Old versions never die. All that happens is they move to other countries. In a lot of other countries, people are using MS-DOS, Windows 95, Windows 98, and they'll keep on doing it forever because they have old machines. And the other thing they do now is they go into the Internet of Things. All the gadgets are running old things. The scanners at the airport looking for the gun in your luggage are running Windows 98 with hard-coded passwords. This is very common. Almost the airplane ticket machines are all running Windows XP. That's because people buy a gadget like that and they expect to use it for 10 or 20 years. And they don't, there's no way that matches with the upgrade cycle of every 2 or 3 years, Microsoft has a new version. They say, well, tough, my old ticket machine is still working, I'm going to keep using it for the next 20 years. Yeah?
You mentioned scanners and guns in the airport.
Yeah?
I was watching the news and I just saw they just presented a new scanner technology. Not really new, it's like when you do an X-ray of somebody, but it's a three-dimensional rotational, and you can. So when the operator is looking at the screen, they can like an iPad, you can grab it, touch it, expand it, flip it around.
That's interesting, but it's not an X-ray, I suppose. It's probably three-dimensional. I don't think they can do it with X-rays, do they really?
Well, that's what I call it, but they use some kind of X-ray technology.
Yeah, it's probably NMR or
See
something.
through it, and then, like, so they showed an example where there was something where the way it was configured, an original, like a normal two-dimensional, you wouldn't see it,
Yeah.
but just by a simple, just rotating it, oh, there's the light.
Yeah, it's a good idea.
Yeah.
All right. Anyway, so Windows 95 was the first version of Windows that wasn't based on DOS. Before this, you could boot up your MS-DOS machine and you could type Win and get to Windows 3.1, which was sort of a graphical game-like overlay on top of DOS. But Windows 95 was not based on DOS to the same extent, although it still used a lot of MS-DOS code. MS-DOS itself was, this is something Microsoft has done many times, MS-DOS was an unfinished product. There was a thing written by some other company called QC-DOS, Quick and Dirty DOS or something like that, that was like a beta test version. And Microsoft made a deal with IBM to provide an operating system when they didn't have one, and they just went and bought one they could find, and that sold it, renamed it MS-DOS and sold it to IBM. This has happened. There was a product called Windows ME that came out at one time, and that was actually a beta version. They got up to the beta level of testing, and then they said, we're going to abandon this product, so let's just sell it the way it is. Anyway, so this brought out a whole lot of features which were pretty exciting, although they didn't work for years after this because they required cooperation, but it had the registry, which was Microsoft's idea to sweep all the configuration files for all the software into one place. You've been doing the projects and using Linux a bit. In Linux, every product is developed by a different team than the operating system. So the kernel is written by one team and other Linux features are written by other teams, and then somebody else makes a product like the Apache web server, and that team there has nothing to do with people writing Linux. So it's not integrated into the operating system at all, really. It just rides on it. So it has its own configuration file with its own format stuck in some folder, and every single program you install has its own little text-based configuration file somewhere, and you learn the programs one by one. And Microsoft didn't like that. That's the way it was in the days of MS-DOS. There were all these little config files all over the place. They swept them into this binary thing called the registry, which includes all the settings to personalize Windows and all the settings to personalize all the software you put on Windows. And that just led to the behavior we've all grown used to, that if you use a Windows machine, it slows down. Every year it gets slower, and that's because the registry has bugs. Every time you install software, it has to put a bunch of entries in the registry, and see, no programmers that develop software write installers or uninstallers. You get them from Microsoft. You run this program, it takes a snapshot of your machine, then you install your software, you run it again, and it creates an installer to go from here to there, and an uninstaller, and the uninstallers don't work right. So they don't really remove all the registry keys that the installers put in. So as you install and uninstall software, you gradually clutter up the registry with junk. It's like barnacles, slows down your machine and causes crashes. That's why there's a lot of third-party uninstalling tools out there. Anyway, that's the registry was there. Plug and play was there. In principle, you could now just plug in a device and it would automatically find the device driver and connect to it, although in my experience this didn't really work until about Windows 2000 with average hardware I could afford to buy. But the feature was available. In order for this to work, the manufacturer of the hardware has to play ball. And then this had the FAT16 file system, which had a maximum size of 2 gigabytes, and like all file allocation table versions, was extremely insecure. The file allocation table system was originally written for floppy disks, and the idea was that the possession of the physical object meant that you had the right to read and write all the data on that object. There was no permission structure at all beyond that, because this came from a time when there was no network at all. You just have a computer and a printer, and anything that went in the computer you'd buy in a box and plug in a floppy disk. So there was no concern of data theft. It would be the same thing as hardware theft at that time. But as we moved on the internet and networks, you now became worried, and now many people are sharing one machine, and yet FAT still had no way to establish permissions for who was allowed to go where on the machine. Windows 98 and ME also used FAT. They had a different version called FAT32 that would let you get to larger disk sizes, but it was no safer. And actually, FAT16, maybe that couldn't even get to 2 gigs. I forget what the limit was. But anyway, yeah, I think it could. Anyway, that is long since gone for Windows hard disks. No modern version of Windows uses it, but floppies use it, and so do a lot of thumb drives because it's universal. Anyway, this introduced System Restore with Windows ME, which was a sort of automatic backup feature that would record some information about your machine so you could roll it back to a previous date. This feature never appeared on the Windows servers because it has serious limitations. It restores file contents, but it does not restore the metadata, like the creation date and the permissions and such, at least some of them. So it actually damages your machine to use it. It doesn't really go back to the previous state, sort of like the uninstaller with software. You install software and then uninstall it, you are not really back in the same state. And if you roll back with this feature, it's not 100% back in the same state. So it is considered unsafe to use on servers, but it's very nice for client machines. When they get messed up and you don't know what happens, you can just roll them back to the way they were a week before, and most of the time, that works. Anyway, Windows 98 finally fixed a memory leak. Windows 95 and Windows 98 had memory leaks, which meant that as you used them, they would allocate memory to store data, and then when they were done, they would forget to free it. So you'd load something, you'd allocate more and more until it ran out of RAM and crashed with the blue screen of death. Windows 95, Windows 98, under normal conditions running Microsoft Office, would work for about 2 hours before they would crash with the blue screen of death. And Microsoft couldn't find the problem, so they put auto-save features in Microsoft Office that would automatically save every 10 minutes, so you wouldn't lose as much work when it inevitably died on you. But by the time they got to the second edition, Windows 98, they finally found that. So Windows 98, you could actually use it all day without it crashing on you, which was a new feature at that time. Anyway, and so then, like I say, here's the TSA baggage scanners. Billy Rios, who is a very great security researcher, gives good talks. He went and showed how to hack the TSA carry-on baggage scanners. Not only are they running Windows 98, they have hard-coded passwords that cannot be changed if he exposed, and they're just kind of amazingly bad as far as computer security is concerned. So Microsoft decided to upgrade to make a business version because they wanted to compete with Novell NetWare, which was running all the servers at that time. And so they wanted to make a business product. They called it the New Technology Windows NT. And this was NT 3.5. It came out in 1993. And this added a central point of administration, the domain controller. So now your company would have a domain like ccsf.edu, and every machine would have a name in that domain, like station1.ccsf.edu, and your domain controller would be one point in the middle that could control everything. So if I want to put out a piece of software or put out a security patch or a software update, like we're all going to go to the next version of Microsoft Office, I can put it on the domain controller, and now everybody that logs in will get that software. I don't have to carry our floppies around, because the old technique where you carry around floppies and CDs and try to update the machines never really works very well, because some of the machines are broken, some of them are in use. You don't really get the update to all machines equally. And so central point of control makes that much better. Also, now you can do things for security. They're really important. Suppose you have an employee that you fire, and they are disgruntled. Now you would like to cancel their account so they can't log on anymore, but in the old days you'd have to run to every machine removing their account, and you might not get them all. Now you can cancel their account at the domain controller, and they won't be able to log in anywhere in the enterprise. That's the point. Anyway, this was much better, and a lot of people still use Windows NT Server domain controllers. I was working a financial case years ago when I worked at an escrow agency with PricewaterhouseCoopers, and they kept sending me bad data, and I found out years later that their entire domain crashed because the entire PricewaterhouseCoopers domain was running on one Windows NT domain controller, which, by the way, is in complete contradiction to Microsoft's official recommendations. If you take the Microsoft certification classes, you can take them here. Lesson 1 about domain controllers is you never have one domain controller. You have 2 domain controllers, because if it goes down, the whole enterprise stops. So you always have at least 2 domain controllers, but they only had 1. Anyway, Windows 2000 Server and Professional. Windows NT started being used for web servers and such, and it got a really bad reputation, and this began Microsoft's reputation for terrible security, because you could totally hack Windows web servers. They were ridiculous. You could just type a directory traversal attack in the URL of your Internet Explorer and go run a command prompt and get a command prompt on the server. You could just come in with Telnet that was turned on, and people didn't even know it was turned on because everything by default had all the networking services running. And so Windows machines would crash all the time, and they get hacked all the time. So this is when people said Linux is more secure, only a fool would use a Windows server. And so Microsoft was pretty offended by that, so they wanted to upgrade their code base, and they brought out Windows 2000 Server and Professional, were a giant step forward. There was a lawsuit at the time saying that they in fact stole a lot of code from Linux to put it inside Windows. But somehow that quietly was settled or crushed. And it certainly was much better. This is the first one that would actually stay up for like months and years without crashing as a server. And so it brought up Active Directory. They were trying to finish killing Novell at this point. Novell used to own the server market, like in the 80s and 90s, they had 90% of the server market, now they're nowhere. They had this thing called Novell Directory Services, where, one thing that's a real drag is you have a company like this, then you buy a new printer, like a color printer that everybody wants to use, you connect it to one machine, and you have to go from machine to machine, typing in a path, leading them to the printer everywhere. And that's a drag, so Novell had this thing called Novell Directory Services, which gave you a central point of administration for things like that. And Microsoft tried to buy the Novell company, but they wouldn't sell, so they bought the developer that made that product to come over to Microsoft to make a copy of it called Active Directory, which turned out to be very popular. And now there's one place on the server where you can specify a new printer, a new location, a new set of machines, and it automatically propagates to everybody else. But this does mean more and more that your central point of administration is vital. So if you want to print, you don't connect to the printer, you connect to the domain controller and say, is there a printer, where's the printer, send this data to the printer. If the domain controller is gone, you're dead in the water. That's why you don't have just one domain controller. Anyway, Windows XP was a huge hit, although people may not remember how much everyone screamed when it came out that the graphics were confusing, they moved everything, it's just full of useless eye candy. Windows 2000 was great, just like everyone said the same thing about Vista and Windows 8. Anyway, this was when Microsoft made their big step forward. Windows XP came out and it was more of the same inside and was getting hacked right and left. And so Bill Gates wrote the Trustworthy Computing Memo in 2002, which reversed the entire security posture of Microsoft because everybody was getting infected, and Microsoft had specifically designed, until this point, insecure products because they said security is a waste of time, there aren't very many hackers, people are just trying to get their work done. All we want is to develop products where an honest worker trying to do their job can do their job and not waste your time worrying about malicious attacks. And they reversed policy and said we're totally going to change it and make security a top priority, even though this means that we will have less functionality and less new features and be more difficult to use. In order to get all that security, we're going to accept all that. And one of the controversial things he did at Microsoft was he took the new operating system they were developing called Vista, and he changed it into Windows XP Service Pack 2, and gave it to everybody for free, which panicked everybody at the time, because Service Pack 2 was 1.5 gigabytes, which was as big as the entire Windows XP. So it replaced all of the code in the entire product. Now this is because Microsoft went around and found out that none of their programming staff knew anything about security. Nobody even knew what a buffer overflow was, so none of their programmers had any clue about how to avoid any of this. So they wrote a book called Writing Secure Code. They stopped development on Vista, made all their staff read it, and they rewrote XP from zero with all new code. And that's what Service Pack 2 was. And the result was XP got a lot more secure, and Vista was a terrible disaster in the marketplace because it had nothing new to offer that anybody wanted because you'd already got all the goodies for free in Windows XP Service Pack 2. So Microsoft really lost several years of profit to do that, but in retrospect it was certainly the right move because PC users were correctly getting very worried about their security, and they weren't going to put up with Microsoft's old insecure policies much longer. And so Service Pack 2 added the firewall, which made you a lot safer by blocking all unexpected incoming traffic, and it turned on data execution prevention, which implemented a motherboard feature called NX, so RAM could be marked with permissions. In the past, RAM was just shared all the same. Now you can allocate a block of memory that would be not executable, and that's where you'd put data, like network data and data that came in from the user. You put it in this non-executable portion, so even if a hacker finds a way to inject code into the data, they can't execute it because it's non-executable. The program will just stop when they try to inject to run that code. And also Windows File Protection built a thing a little bit like Tripwire into Windows where it would know what the hashes of critical system files should be and be able to fix them if they get altered. All right, so Windows Server 2003 was the server product to go with Windows XP. It also had a giant service pack called Service Pack 1, which rewrote the whole thing to bring it up to XP Service Pack 2 standards. And after this came out, Microsoft said we no longer support any version of Windows earlier than XP Service Pack 2 or Server 2003 Service Pack 1, because those products were written when our entire programming staff had no idea about security, and we will never be able to find all the flaws and fix them, and we're not even going to try. If you want any assurance of security, you must start with at least this code base, not that code base. And all right, so then Vista came out, which added a few new security features that were very annoying and unpopular. Well, user account control was when Microsoft finally added a feature that Linux had from the beginning. All earlier versions of Windows, people typically logged in as administrator and ran all day as administrator all the time. You'd be browsing the web as administrator, so if some website installs software, it has administrator rights to put it anywhere on your machine, and Linux has never been this way. You run as a non-administrative user, and you elevate to administrator with sudo or something when you have to, client-side versions of Linux anyway. And so Windows Vista added this user account control where you're not the administrator all the time, and every time you attempt an administrative action, it'll ask you to approve it. The original version would pop up every time you did almost anything. This thing would pop up asking you to confirm it, which would drive you nuts. They also added BitLocker, although they made it only available in the super expensive version that nobody would buy. But BitLocker was the first full disk encryption, which is a response to portable computing. There's no reason to encrypt a server in a server room because it has to be running all the time, and it has to be able to decrypt the hard drive to use it. So an attack against that server typically comes over the network, runs malware on the server and steals the data, and encrypting the hard drive won't protect you. You encrypt the hard drive for phones and portable computers like this because a risk is someone will just steal the whole thing. And then they're going to have all your data, and if you have something like a Windows password protecting it, that's useless because they can just take the hard drive out and read it on another machine, or boot it from a thumb drive or a CD to a different operating system like Linux that does not recognize any Microsoft Windows passwords and copy all the data off. So the only thing that will save you is if the whole hard drive is encrypted. And then all the data they get is scrambled and they can't read it. And that's what BitLocker does. The other thing they added in Vista was address space layout randomization that moves all running programs to random locations in RAM every time you reboot, so that if an attacker injects code, they can't find the code they injected, which again makes it more difficult to do buffer overflow exploits. Yeah?
Is ransomware using the same mechanism when it comes to encrypting the hard drives?
Yes, that's a very good point. The better ransomware does in fact encrypt your hard drive, typically with AES, which is the modern recommended standard, and then they put the key on the server. Yes, so I think they both use the same fundamental technique. The difference is when ransomware encrypts your hard drive, the key is no longer present anywhere on your machine. When BitLocker encrypts your hard drive, the key is stored in a special chip called the Trusted Platform module on the motherboard. So it's on the computer, but it's very hard to steal. The reason it's hard to steal is because during boot up, the TPM decrypts the hard drive, but the processor has no access to the TPM at all. So you can infect the processor and get it to run any code you want. The keys are not anywhere in the accessible RAM. They're on a special chip.
Is that the same on UEFI as it is?
UEFI is just another way to boot up. I think that's another advancement that came out around the same time, but it's not connected directly.
Okay.
You can have a TPM without UEFI or with UEFI. It is, however, the same thing as a secure element on iPhones. iPhones have the same thing. That's why it is supposedly very safe to put all your credit cards in your iPhone and use Apple Pay, because they have a special chip to put the data in that is not accessible to all the apps.
Is it a symmetric key encryption?
Yes,
Okay.
usually AES.
Okay.
Now, by the way, there's also quite a few ransomwares that are buggy. There's an Android ransomware that will encrypt the data on your phone and demand payment, and when you pay, you won't get anything because it just destroys the data. It doesn't actually encrypt it. They don't really have the key. There are several versions of ransomware where the key is actually still around and you can decrypt it without paying the ransom, or the key is always the same and that sort of thing. But the more professional ransomwares do the right thing. The key is only available on their server, and there's no way you can get your data back without paying the ransom. So the cure, of course, is to run backups. So you have another copy of your data, but people usually don't run backups, in my experience, until they have seriously been hurt maybe 5 or 7 times. And then they begin to realize, I really need to bother backing my stuff up every week. So I'm not going to do it, but you can see address space layout randomization is Process Explorer. And so here I did it on Windows 7. You boot up, you run Process Explorer. You can look at the explorer.exe process, which is the process that draws the desktop. In the Mac, it's called Finder. In Windows, it's called Explorer. And you can see down here, ntdil one of the important libraries used, is here loaded at 76DB000, but when I reboot it comes up at 77D4000. There are two things to notice here. One is that every reboot causes a randomization, which is what makes you more secure. The next thing is to notice, this is not what I would call very intelligently random. The last 4 bytes are all 0, the last 4 bytes are still all 0. This is 76, that is 77. That might make you wonder just how random it is, and that's a good thing to wonder. In fact, most processes randomized by Microsoft's ASLR are only given about 12 bits of entropy. So there are really only about 4,000 different random locations. So one way to defeat ASLR is to just run your attack 4,000 times, and you'll get lucky, and you'll be where you expect it to be. And that is kind of ridiculous, but this is the thing I've learned about all Microsoft security measures. They all do about half of what they should do, because I think they have a giant burden of legacy code. They can never do the full implementation of anything. They always have a sort of crippled halfway implementation of things, and you get used to this. But it did slow people down. So Windows Server 2008 had all these features. It also had network access protection, which is another way to identify devices that are connecting. And it had Server Core, which is a response to another thing that people always loved about Linux. If you want to run Linux, you want to have a small computer doing a special thing, like the early motion towards the Internet of Things, where you have a server that really only does one job, you can very easily strip down Linux and make it very small so it has just the essential pieces. And some people have known how to do this for years at Windows. They walk up to your Windows machine, they throw like 90% of it in the trash, and they're there, now it'll run faster. And Microsoft finally made an official version called Server Core, which is this, just the essentials, no graphics. You control it remotely from another machine. Command line only installs in like 10 minutes, which is pretty fast at that time. Only like 2 gigabytes instead of 8, you know. And then they had their enterprise class virtualization client, Hyper-V, which didn't work very well until about 2012 R2, but now it's considered a serious competitor to VMware's ESXi. Now in our projects, we're using VMware Player, or VMware Fusion, which are the client desktop products, and those are basically just for learning and for software development and stuff. They're not for, but servers run on their enterprise class platform, ESXi. Almost every web server you connect to is running on that. So make sure I got the right version. I do. All right, good. So, all right. So Hyper-V is coming out. Then they came out Windows 7. There was a big concern when Windows 7 came out that software designed for XP would not run. Microsoft included a lot of very clever compatibility features so that if you take a program designed for XP and install it on Windows 7, it will be presented with an environment that fools it into thinking it's on XP. And that in fact works very well. And almost every piece of software I've ever seen designed for Windows XP runs just fine on Windows 7. But in order to sell it to businesses, Microsoft included a free virtual machine running Windows XP with every business version of Windows 7, so that you could do that if necessary, because everyone was very worried that their all-important software would not run on the new version. User account control was also made weaker and therefore better. So user account control would now only ask you if you did something suspicious to verify what was happening, and not every time you elevated to administrator. So from some mathematical point of view, that's less safe, but in practice, it's much more safe because in Vista, everybody just turned it off because it would drive you nuts. And this is a fundamental issue of all security measures, the boy who cried wolf. This happened to Target. Target got hacked about 3-4 years ago. It was one of the huge retail hacks. They came in through the air conditioning repairman's account. And after Target got hacked and they lost some millions of credit card numbers, somebody said that Target had FireEye, which is cloud-based security that scans your incoming connections and emails. They said FireEye should have alerted them to that. And then people that had FireEye said, yes, FireEye gives you 10,000 alerts a day. It probably did. Nobody can look at them. It doesn't save you for that reason. You can't do that. You can't drive people nuts with a lot of false warnings, or they will just figure out some way to turn it off or ignore it. Anyway, Windows 8 had Microsoft's built-in antivirus, which looked pretty good until people actually tested it and discovered that it was appallingly weak, and Microsoft has now had to admit that Windows Defender, which is what it is now, is essentially completely useless. It shouldn't even count as an antivirus product, and you have to go buy a real commercial one to go along with it, because most independent tests of antiviruses don't even test it. They say it shouldn't even count as an antivirus product at all. It is so much weaker. Even a professional antivirus like Kaspersky or Norton will usually only stop about 3% of the threats. So antivirus has kind of come and gone. A lot of people are beginning to recommend not even running antivirus. Most people think you should still run it because it will stop some attacks, but you certainly can't imagine that because you're running antivirus, nobody's hacking into your machine. It doesn't provide that security anyway. The one thing Microsoft does do quite well is block phishing attempts. They have an online list of all the known sites that are serving up malware, and every time you connect to anything with Internet Explorer, it checks the online list. This led to people getting really worried about what they said was Microsoft spying on them. Every URL you go to is in fact sent up to Microsoft, so they could be spying on you, but what they say, they are not spying on you, they're just accessing the list to see if that's a bad URL. Anyway, it's the game there. Windows 8 on ARM, which is just one product that almost nobody bought, an iPad-looking tablet that runs on ARM. That thing actually had UEFI secure boot, which means it verifies the digital signature of the operating system on every boot so it cannot be altered. This is what iPhones do and what iPads do, which is why you can't infect them with rootkits, one of many reasons. And this would make it possible to build devices that cannot be infected with rootkits, at least not the usual kind of rootkit, because you can't alter any system files without that signature verification failing. But there are very few devices actually implementing that feature. Anyway, Windows Server 2012 is the latest version. There's 2016, but it's out, I think, still in just a beta. I don't think the official product is out. 2012 added a protection against pass-the-hash attacks. This is a very strange thing, but Microsoft you can look in a Windows machine and find a password hash, which is how it's stored on the hard drive, or in that case, you can steal it off a network, and then you can just replay it to log into a server. So if you find a hashed password, you don't need to crack it to use it. This attack has been around for a long time, and Microsoft finally had a defense against it, which they built in here, and I'll talk about it a little later. And Windows 10 brought back the start button, so it's almost as usable as Windows 7. I mean, Windows 8, the main thing is to change the entire environment and the process of doing everything, so all the experienced users can't figure out how to do anything. Everyone screamed, and they fired the whole team involved, and Windows 10 made it look a little bit more like Windows 7 anyway. This has a few more security features, but the most interesting thing is the pass-to-hash feature, which we'll get to. Windows Server 2016 is going to have containers, like Docker containers. Containers are like virtual machines, so you have your own different machine to run a process on, but they are much less separated from the host operating system than virtual machines, and they're considered much less of a security boundary. A virtual machine, like the kind you're using, you have, say, Windows 10, and then you run a Windows Server 2008 virtual machine on it. It sets aside maybe 10 gigabytes of space and has an entire second copy of all the files, entire copy of all the server files. Even if some of the files are identical on the host and the guest, there'll be two different copies. In containers, you have this thing called overlay FS, where you have all the files from the host system, and then you have different versions of them available. So if you have a Ubuntu Linux machine and you put an Ubuntu Linux container on it, it has size 0. It's just an empty folder. Then as you begin installing software in the container, it makes a note of which files are different than the host and has only them. So fully running server in a container can be 10 times smaller than a virtual machine would be. So you can run dozens or hundreds of them on the same host, but they are less separated from the host, and it is not as secure in that regard. But it's very popular. Many people are using this. It's a fantastic technology, and Microsoft has gone so far as to actually come on board and join with Docker and promise to open source their stuff. So there are supposedly Windows containers available in Server 2016, where you can run Windows on Windows in the new container technique. And that's probably something that will be a huge hit because it's much faster and cheaper on the same hardware. But as far as I know, nobody's using that stuff yet because it's all still in beta. So NetBIOS is this interface intended to let you share on a local area network, share printers and files. You'd have this name that might be 16 characters long, with the last character tells you what type of service it's running. The suffix would tell you it's a workstation, it's the master browser, various other things here, like a router. The master browser was an early predecessor of what later you get for the domain controller. This led to a bizarre thing. The funny thing about Windows machines, if you have, like you bring in a printer and plug it in, the machines will not show the printer if you go to Network Neighborhood, not for a long time. Now in MS-DOS, this didn't happen, because MS-DOS, every single device on the network would send a broadcast every 10 seconds I'm a printer. I'm a printer. If anyone wants to print, you can print it right here. The printer's still here, so everything was always updated. But this created chatter as networks got bigger to where all these broadcasts were flooding the line. So to prevent that, they have the new system here where they have a process called server. And this thing will elect one machine to be the master browser that has the master copy of the local network, and it will get updated every 12 minutes. Every time a new device comes in, within 12 minutes, it will tell the master browser, and within 12 minutes, your computer will query the master browser to see if something has changed, so it can take up to 24 minutes for a new device to appear on your window, and it often fails completely. So one thing I learned back when I was doing Windows 2000 and Windows XP is you'd put in a new machine, plug it in, it would not appear in any of the lists like network neighborhood, but you could just type start run / IP address and it was there. It doesn't make it to the graphical environment until much later. But anyway, that's what this NetBIOS thing does. That's what this master browser is. Very strange. Anyway, so I got a few icebreaker questions about that stuff. Come grab one if you need one. All right. Take this thing. All right. This is 3, 4, okay? All right. There's my doodad. Okay. All right. So what part of this is included in enumeration? And I'll quit at 35.
Is there more than one answer?
No, can't be. So who is fingerprinting from the outside. Finding a list of account names is enumeration. The most popular answer is correct. This taking over a machine with an exploit, that's exploitation, that comes later. These phases always seem a little arbitrary and not too interesting to me, but it is an attempt to make a scientific model of how hacking works, and it is a pretty big deal if you take the Certified Ethical Hacker exam, which is one thing you might want to do, although the only people that respects that cert are the military, as far as I know. In the private sector, the OCSP is the one that penetration testers have, Offensive Security Certified Professional, OSCP, which is much harder and based on Linux. But anyway, if you take the CEH, which I did, they do want you to know all these phases and what makes them different than the other phases.
Wait.
What's that?
Okay.
Yeah, enumeration. Yeah, so which one of these is not part of enumeration? All right, looks like I can quit at 35 again. All right, and the rest of these things you actually get, but you don't get account numbers. Actually getting, data stored in some database like that is something you get after exploitation. It doesn't hand that out until you actually log in as somebody or find some exploit. Microsoft, unfortunately, in early versions would share all these things. It would even tell you who the administrator was and so on before logging in. Which version first had a firewall on by default?
Firewall.
Mhm. I'll quit at 30. All right, that was Windows XP, Service Pack 2, Windows Firewall, very effective at protecting you. If you take an unprotected old version of Windows XP before the firewall and connect it to the internet and just wait, it will get infected after 1 day. If you just turn on the Windows Firewall, it will take 1 year before it gets infected. So it was a big step forward in terms of real security. All right, which version first had a firewall filtering outgoing traffic? Something I wanted to talk about. I'll quit at 30. All right, the answer is none of them. Even the current ones do not filter any outgoing traffic. This is because Microsoft wanted to put it in Vista. See, if you get infected by something like the I love you worm, your machine will now send out a whole bunch of emails to everybody you know. It's easy to detect a sudden flurry of identical emails all coming out faster than a human could send them and block that. And they said, Microsoft said, why don't we block obviously malicious outgoing traffic? And the big corporations like HP said, we will not accept a firewall that blocks any outgoing traffic because we have custom applications in our network which use unexpected ports, and your firewall might block them. And it's too much bother for us to have to deploy some kind of group policy to open those ports. So Microsoft never blocked any outgoing traffic by default. This is part of a big issue on the internet called egress filtering. The same thing applies to companies. City College, for example, some machine here might get infected by some kind of malware, and then it might start sending out a bunch of attack packets with forged from addresses, so they appear to come from some other location than the college. If that happened, we could clearly block them on the way out. On the way out to the internet, at our internet gateway, we could say no packet can leave that doesn't have a from address from our IP space. We're not going to let anybody lie about who they are. Anything going through that point, we know it comes from our IP range. That's called egress filtering, and nobody else can do it. As soon as it hops onto the internet, none of those routers know where the packets are really coming from, so they can't do it. This has been recommended for decades, but almost nobody bothers because it's contrary to capitalism. You're spending money up maintaining a filter which protects your competition from being attacked by you. It doesn't make your machines any safer, it makes other people safer. And this is part of the big philosophical issue called the tragedy of the commons. There are a bunch of cases where for you to make money, you can do something that hurts somebody else. And people have a natural incentive to do that. Like, you know, chop down the rainforest, it won't grow back, but I get money today and who cares? And anyway, and it's the same issue here. So none of the Microsoft firewalls will filter any outgoing traffic, even when it's obviously malicious. You can turn that on, but it's not on by default. Yeah?
In something like that, how would you differentiate between e-blasting something out?
How would what?
You e-blast something.
E-blast, you say?
Right. You send a message out to a group of people
Yes.
in your company?
That's right. So it would have to detect, you'd have to have some rules, like some limit. I know Gmail, for example, I think only let you make 50 copies per message, and they'll block you beyond that to try to stop you from sending spam. So you're right. That is, of course, another issue, is you have to have some good way to detect malicious from non-malicious traffic. Anyway, but you can do this with an intrusion detection system. But the firewall doesn't block anything on the way out. Anyway, so, all right, when did user account control come out?
I believe that's one of
Putting
the
it
questions
30.
that was, I had to look up, that was not in the chapter.
All right, I thought it was, but I'll check. Anyway, this is Vista. And by the way, Vista was the official operating system for the US Army. I know I was teaching a Vista certification class, and Windows 7 came out, and I said, I'm really teaching Windows 7. One student complained, I really need Vista certification because the whole US Army standardized on Vista. I think after that, they standardized on Windows 8. They always seem to choose the worst product to standardize on. I kind of wonder if some money is changing hands somewhere, but anyway. All right, so which version includes antivirus? Yeah. All right.
Hard, this chapter.
I'll put it at 30. Yeah, I know it because I lived through all this stuff. Anyway, that was Windows 8, had their antivirus engine, such as it is. It's not very good antivirus, but it's something. All right, and let's see, it's just about 10. Let's take a 10-minute break. We'll pick up at 10 after, and we'll finish this up. Let me stop this recording, which is chapter 6.